I'm Neil deGrasse Tyson, the director of the Hayden Planetarium at New York City's American Museum of Natural History. And I've been asked by the producers to investigate the science behind the movie Ice Age Collision Course. You've seen the effects of space travel, planetary shifts, and the force of gravity. But how do they actually work? For these answers, you'll need to ask an expert in astrophysics. Luckily, I am one. So bring it on. First question. In the movie, Scrat reaches the moon in 16.5 seconds. How fast would Scrat have to be traveling to reach the moon in that time? You know, it's not how fast he gets there, it's how quickly he'd have to accelerate to reach the speed necessary to get there in 16.5 seconds. And that acceleration would squash him into a pile of goo at the back of the spaceship. The moon is about 250,000 miles away. 250,000 miles divided by 16.5 seconds. Carry the 2. Comes out to about 16,000 miles per second. That's how fast. Next, Scrat accidentally does everything. Scrat accidentally forms our solar system at the beginning of the movie, which takes place in the Ice Age. How long ago was our solar system actually formed? There was a lot of loosey-goosey movement with the timeline in this film. You know, we think the Ice Age was like a zillion years ago, and it was like tens of thousands of years ago. Dinosaurs went extinct 65 million years ago. 1 billion years ago, we had single-celled organisms. 4 billion years ago, the solar system was formed from collisions of objects, orbits unstable, cast hither and yon, and Scrat was there because Scrat caused it. Next question. Scrat uses a tractor beam to shoot a planet towards Jupiter, and it bounces off, creating a big red spot. What is Jupiter's big red spot? Jupiter's red spot is a storm. It is a cyclone, except it's spinning the opposite direction from cyclones on Earth, so we call it an anticyclone. And it's a storm that's been raging for more than 300 years. Jupiter rotates twice as fast as Earth, and your rotation rate gives energy to spinning storms on a planetary surface. So Jupiter has storms bigger than Earth. You can fit multiple Earths inside Jupiter's red spot. So don't mess with Jupiter. Next question. Scrat witnesses 2 planets collide, which results in the creation of the asteroid belt. How do asteroid belts actually form? Well, we know we have an asteroid belt, and it's a region of craggy rocks between the orbit of Mars and Jupiter. Asteroids are pieces of planets that have broken apart and collected in that belt in orbit around the sun. There's countless asteroids there. But if you glued them together into one single object, one single mass, you get like 5% the mass of our own moon. So there's really not much total material there. Our asteroid belt is not nearly as massive as the one Scrat witnessed. But I think Scrat created that asteroid belt. He was messing everything up in the early solar system. No, I shouldn't say he messed up. He turned it into the solar system we have come to know and love. Thank you, Scrat. Next question. What are the conditions of an electrical storm like?
Hurry, Granny! Don't you hurry me! I've been struck by lightning more times. Granny! Then you've had hot breakfasts.
Can static electricity actually be harnessed?
Oh, no.
We're all familiar with static electricity. You know, you're wearing socks, took your shoes off, and you're on a wool carpet, rub your feet, and you touch the doorknob, there's an electric shock.
Everyone,
try not to create any sort of friction. No friction. Got it.
Yep, cool beans. Friction is what now?
When you build up charges over here, and if there are more charges here than there, and you bring them near one another, it'll gap across the air and transfer until they're exactly equal. Because electricity doesn't like being unequal. In Ice Age collision course, all these rocks have extra static electricity sitting there. No. That gets a D- if I were to grade it. Because the rock is sitting on Earth, and the Earth is this huge repository of charges. If you have excess charges on a rock, and the rock is sitting on the ground, the charges go into the Earth. Like that. I'm not going to wait around for you to walk through it and then send charges back and forth to you, as they did in the movie. So it was fun to watch everyone get electrocuted several hundred times. So I'll give it to them. This movie features magnetic crystals. Are there magnetic crystals? How do they behave and where do they come from? Actually, any crystal I've ever played with was not magnetic. And none of the crystals in a geode are magnetic. So I don't want to say no on this one. I'm going to say I don't know. Sorry, I can't help you. I'm an astrophysicist, not a geologist.
Simpleton, nincompoop.
Next question. Would you be able to alter gravity in space like Scrap does in a spaceship? In supergravity mode, why does the acorn flatten Scrap out? On the alien spaceship, they can control the force of gravity with a lever that he happens to knock into gravity mode 56G. The acorn now weighs 56 times what it did before. Now, acorns don't really weigh that much, an ounce at most. So 56 times that, that's like 4 pounds. Yeah, there's no reason for it to completely flatten out. Given other things that Scrap goes through in the movie, like doors slamming on him. And I felt sorry for him, but not when the acorn rolled over him. No. I felt sorry for him when his teeth fell out. Next question. When Scrap is floating in space, he's able to move around at varying speeds. Is this actually possible? Well, unless you have retro rockets, or you can strategically divert in one direction or another. Once you're floating in space, you will continue floating in that direction until some force acts upon you from the outside. That's one of Newton's laws of motion. They've known that for hundreds of years. So, unless Scrap's got alien technology, all bets are off. But if he's just floating, no. He'll just float. Forever. Unavailable to make another movie for you. One last question. Would you be able to hear Scrap scream in space? If Scrap is in a spaceship, and that spaceship has air, and Scrap screams, yeah, you'll hear it. The sound waves vibrate the air molecules, and it'll go from Scrat's mouth to your ear. Sure. If Scrat is in a spacesuit in space, and Scrat screams, you're not going to hear it. You have to stick your ear on the helmet. And then you can hear the vibrations from the mouth, through the air in the helmet, to the glass of the helmet, to your eardrum. But through space,